Okay, so unfortunately, there isn't a UVOT equivalent of our user objects. So the online XRT product generator, there isn't one of those for UVOT as such, I am afraid. We at Leicester, so Andy and me and Phil who wrote this, we are XRT team members. So Swift as a whole and XRT, we're not the UVOT team. So please don't blame us for this. However, there is it's not as comprehensive by any means, but there is a way to get quick magnitudes. I mean, honestly, the UVOT tools for getting magnitudes are quite straightforward, but there is a quick way to get it on the Italian web pages, actually. So I mentioned that there were ways to get the data from the Quick Look and the archive that are both, well, they're available. Everything is available from the US website, the UK website, and the Italian website. The Quick Look sites are, so we all provide same data, but slightly different extra bits. So at Leicester, for example, we reprocess the data as they come in to make sure we're using the most recent version of the software if you really do just want to look at the cleaned event list that's already available, which I don't recommend, but it's there if you do. The Italian guys have this option for, so their interactive archive for the XRT is more basic than our XRT product generator, but was around before, so still there. But the UVOT is one that we don't offer. And you click on those, and then it tells you which filters are available. So I actually mentioned the 6 filters and the broadband white filter that exist for UVOT. So some observations of sources will be in all of the filters. Some might just be in one, some might be in combination. There are different reasons for this. It could be somebody's science requests, but there are also limits to we can't always use the filters if there's a bright source in the field of view. So it might not even be your source of interest, but if there is a bright source in the UVOT field of view that is too bright for a limit in so it's a bright star checker we have. If any of the filters are any source in the field is too bright for the filters, we can't observe it in that. So, you know, you can't override this. So Swift, no, can't do that. So you can't always observe everything in whichever filter you might want. But you can, this gives you an option and it will just whiz through things and it will give you a quick magnitude. But as I'm going to show you, it's actually very easy to estimate magnitudes. So UVOT operates, so we have, for XRT, we have window timing PC mode. UVOT has image or event mode, or image and event mode. So image mode means that there's one observation, say we have one snapshot and one filter. One snapshot would be one image. So the snapshots can be divided between different filters, so different images and filters, but you'd only get one image per filter. So it's the exposure as a whole, you just get an image. You don't have the times the individual photons arrive. Whereas if you have event mode, it's like for XRT, you literally get an event list which tells you the times all the photons arrive at. So the vast majority of UVOT data will be collected in image mode. Early GRB observations have both, and you can request event mode data if you have a good scientific reason for your observations, if you put in a target of opportunity request. The reason we stick with image mode is that it's less telemetry, and there's no point collecting all the time tagging of photons and downloading all that extra data if nobody cares about it and they just want an average magnitude. So the file names are very similar to the XRT ones. We've still got the SW, the OBS ID, and segment number. We then have U, as I mentioned, for UVOT, and then you have 2 letters which identify the filter. So it will either be VV, UU, BB, W1, M2, W2, or WH for white. And then we have the sky images, and there are also exposure maps and the raw images, which are basically in detect coordinates and aren't much use for most things. So aspect correction. This aspect correction basically means having the correct RA and dec. That's the short thing. So you need to know that if you're looking there and the source is there, you know that that is the RA and dec that it says it is. Now, the UVOT data are aspect corrected automatically. There will, however, sometimes be times when the aspect correction fails. It might be that there actually is a problem with the data. So say the spacecraft wasn't stationary, it's at the star trackers, we could be drifting for some reason. Or it could be that the star trackers have lost lock, so Swift didn't actually know quite where we were pointing, so it's got a bit confused about what RA and dec is what, and that might not work. Or it might just be there aren't enough catalogued sources in the field of view that can be used for aspect correction, because the system basically sort of says, oh, right, well, we know that star is meant to be there, that one's there, that's there, so right, we're looking in the right place. That is, it doesn't happen all that often, but if it does, it's more likely to be in the UV filters, because there are fewer UV known sources in the catalogues, whereas there are a humongous number of V band stars, for example. So if you check it by checking the keywords, so in all the files have a lot of information in their headers, keywords telling you the name of the source, RA and dec. And they also have one called ASPCORE, which is aspect correction. If it's set to direct, that means yes, it's been corrected. If it says none, it means it hasn't. Now, if there is a file in there that says none, there's no point running the default correction, because they have all been done. So it's, if the default didn't work the first time, it's not going to work again. So there is a task called UVOT Unicore, which always makes me think you've got unicorn, but it's not. It's a way to correct it. And in this case, you actually sort of, you look at images and you match them up by eye and say, oh, well, that one matches that in this image, and that one matches that, and it will try and rotate them. It's not easy. It is quite fiddly. And honestly, unless you desperately want to correct one image that's really more important to you than any other one, most of the time, if the aspect correction has failed, well, you can actually use it if it's not being aspect corrected. If all it is it's sort of not quite in the right place, if you know which source is yours, say you're looking at one thing and that's the only one in there, even if the RA and dec are in the wrong place, or it appears to be at the wrong RA and dec, you can still measure a magnitude, but you can't combine the data if any of them don't have the aspect correction. But usually it is just easier if one is not aspect corrected and you've got more data, just use the other data. But I'm not volunteering to go through UVOT Unicore with you, because I've only done this I think twice, and I was tearing my hair out. So, yeah. Oh, and yes, occasionally, even if it says the aspect correction is correct, or direct, I guess, you might see point sources are slightly elongated. It doesn't happen very often now. There was a while we had a problem with the gyros and things. So Swift moves through spinning gyros, and yeah, about 2 years ago, I guess, there was they weren't holding Swift as stationary as they should have been. We had this, we referred to it as jitter. So although we seemed to be on target and pointing, we sort of had this jittery, and it didn't show up in the XRT because our pixel size was bigger, point spread functions larger. But for UVOT, you did get some jittery things, and it could look. So a point source no longer necessarily looked entirely point-like. And even now, although that's fixed, occasionally the aspect correction will say that it's been done, but it might not look perfectly point source-like. Usually it's better to drop those data. So it's a good idea to check your data by eye before you start measuring magnitudes and things. Okay, so assuming your data are aspect corrected, then you might want to add them up. So we're sticking with image mode for now. Maybe you've got a faint source and it's not detected in just one single snapshot. You might want to add them all up. So there is a script called UVOT IMSUM. And assuming you have multiple snapshots in one observation, UVOT IMSUM can be used to add them all together. So as I said, reminder, snapshots can't be more than 1.8 kiloseconds long. If you're using UVOT and multiple filters, the exposures are probably noticeably less than 1.8 kiloseconds. So you can add them up simply by that. So you can do this if the file is still gzipped. That's the way they're stored in the archive, the zipped files. But if you just say you've got IMSUM, it will add up all of the individual images in there, which are aspect corrected, and give you a summed image. You edited the old file. Sorry, there's a better way to do this. Andy sent me an updated PDF, and it didn't occur to me to check this. Hold on a minute. Have I got the? Let's see if I can get. Actually, yeah. Let me see if I can get that one. Sorry, everybody. It hadn't occurred to me that to check that. There we go. We'll do final. That one. In fact, this should be fine now because the rest of them are the same. Okay. We'll combine these before they get uploaded. Where are we? Almost there. Sorry. Right. So yeah, this I only discovered last week when somebody sent a question to our help desk, and I was answering it. So I suddenly realised that if you want to sum multiple UVOT images together, it's a lot easier than it used to be. So sometime between me working out how to do all this about 20 years ago and answering a specific question last week, the UVOT team improved UVOT IMSUM. So now I know how to do it a much easier way. So it used to be UVOT IMSUM would only work on one image at a time. Now you can give it a list of images. So if you just give one, it will add up the individual extensions in that one image. If you give it multiple images, it will add up all the extensions in all of the images and give you one output at the end. So that is much easier than the version on the screen that I just disappeared, moved away from. So that's how you sum images. You might want to find out if your source is detected. I mean, if it's a bright source, you'll be able to see by eye and go, yep, it's there. But say you want to know whether there is an actual detection, if you squint and see whether you believe it's there or not, then UVOT detect is the way forward. If you include the command plot source equals yes, it will pop up this image in DS9. So the image, the background image is your input file, but it will draw all the detected sources, draw circles, well, circles or ellipses actually, over everything that it thinks is detected above whatever threshold you give. So I know the UVOT team will sometimes set things down to a 2 sigma detection threshold. Personally, I like things to be at least 3. Apparently you can go up to a detection threshold of 100. Never tried that. But it will show all the things that it detects in the field, and knowing the RA and DEC, so the output file, as well as this plot, there is a file that lists every source with the RA and DEC in the file. So as long as you know the RA and DEC of the source that you want to know detected, you can find if it thinks that it is. Honestly, using the exposure map doesn't generally make much of a difference if your sources are in the field of the center of the field of view and there's just one image. It's if you've got summed images and they're at slightly different positions and things, then the exposure map can be useful. Okay, so whether you've got a single image or a summed image, you probably want your magnitude or want to measure magnitude, and UVOT source is the way to do that on a single exposure. So in this case, we're using this little circle. The calibration for UVOT was done using a standard extraction region of 5 arc seconds. So if possible, a radius of 5 arc seconds is the best source region to use for UVOT. You shouldn't go bigger than that. This is for point sources. If you start getting extended galaxies and things, then don't ask me how to deal with it. Ask the UVOT team. If you might want to go have a smaller extraction region, because sometimes you have sources close to each other, and you don't want, if a 5 arcsecond region could be around your own source and actually be contaminated by an adjacent one. So you certainly can go down to smaller ones. 3 arcseconds I've used. So I can't remember what the pixel size is for UVOT, but you can get sub-arcsecond images, positions for UVOT. So 3 arcseconds is certainly not a problem. So you define a source region. Again, define a background region that's bigger than the source region. You can either have one larger circle like that. You could use an annulus. You could use multiple little circles. And just make sure that it's not got other sources in where you think is the background. So, join a circle there. That would be contaminating background. You don't want that, obviously. And then, again, as I did, I'm going to show you, it will prompt you through all the inputs. As Andy showed for the timing, almost all of these things, you can put everything on the command line. So if you start scripting things up, that's the way to do it. But for teaching and introducing, I find this much easier, and it also saves typing horribly long command lines like Andy did. So UVOT source, as I said, works on one extension at a time. So you might have multiple snapshots. If you don't put the +1, it will automatically do the first one. But if there's a second snapshot, if you put +2, it will work that out. But UVOT source will just do one at a time. And you give it the source region, the background region, the threshold at which you want your detection set. I tend to use 3 as a minimum, and then some sensible name, because the FITS file will have all the information, so much information. It will have the times, the time of the observation, the filter, things like that, and then it will give you the magnitudes, so Vega magnitudes, AB magnitudes, fluxes in various different units. It will give things that I never really understood what they're telling you, but it will give you a lot of information. However, it will also write the basic information straight to the screen. So you will immediately see what the magnitude is, both Vega and AB, and what the flux is in ergs per square centimetre per second per angstrom, I think, is written to the screen. But there, as I said, there's even more in the FITS file. If it's not detected according to UVOT source, it will tell you. It will say that the magnitude is greater than whatever, the flux is less than whatever. But there's one thing to be aware of. You might get a magnitude that says 99. Well, that doesn't make sense, does it? And that's because there are certain areas on the UVOT CCD where the throughput is lower. So these were mapped a good few years ago now. At the beginning of the mission, I'm not sure if they were there, we didn't realise, but it certainly got worse. If your source overlaps one of these areas, the software will know it, and it will flag it up, and it won't give you a magnitude measurement because the value would be wrong. So I should point out that so that's written to the screen, as I said, the standard output, it will give you the magnitude as 99, so you can't really miss it. But if you look in the FITS file and the output file, and you just went straight to the flux, you didn't notice the magnitude saying 99 or whatever, you went to, or the count rate, which is minus 999, you went straight to the flux, it actually gives you a value, even though it's wrong. For some reason, it's not flagged with 99 or anything like that. I've mentioned this to the UVOT team before, and I'm not sure why they didn't think to do it. So just beware, even if it's the flux that you're interested in for your plot or whatever, always check to make sure that the magnitude is an actual number or a sensible number, not 99, before you start using your fluxes. And also, if you use UVOT source on a summed image, if one of the extensions was in a bad spot and he looked at that extension on its own, it would say 99. When you start summing them, you lose that flagging because they're in different places on the CCD and things. So if you're very concerned about getting an accurate magnitude, check the individual snapshots before you start combining. One thing to be aware of is, well, we mentioned that UVOT sources can be too bright. So they can be too bright so that we actually can't detect them, but we can't observe them because it would be dangerous for the instrument. But there are also ones that it's safe to observe, but it's the equivalent of XRT being piled up. It's known as coincidence loss in UVOT. So I think I've got, yes, I do have another plot. This is just to warn you that if you see something like this with a vague square pattern around it, that's warning you that it's likely to be coincidence loss. This is actually referred to as mod 8 or fixed pattern noise. It happens all the time, but if a source is not too bright, if it's a standard source, it gets masked out in there's a tool, I think it's called UVOT mod map or something. So when it processes the data to get it into the clean sky image, it all gets removed. But if it's a coincidence loss source, if it's too bright, it changes the characteristics of the image or of the source, so it can't recombine it properly. So you get this weird square pattern. And sometimes you'll get this, this is known as a smoke ring, and you can get things like that if you do have bright sources. It's due to an internal reflection within the instrument. There are other problems you can get in UVOT images as well. So like I mentioned, there was the readout streak in the XRT. We get those in UVOT as well. They can actually be useful for UVOT though, because there is a method, which I can't remember if I've given the link or not, but you can actually use the readout streak to get a magnitude from a source which is too bright for standard photometry. It gives you an extra 1 or 2 magnitudes, I think. So there is a paper by Matt Page, not this one. This is just this image. I may or may not have linked to it. But please, again, another thing not to ask me how to do, because I have not figured out how to do it yet. Ask me XRT questions, those I'm happy with. And you may be able to see there's a sort of slightly brighter bit there. That's known as a halo ring. That's also, you know, these internal reflection problems. So it's all of the, well, apart from the coincidence loss and the readout streak, the other things are fairly rare. The diffraction spike, the smoke ring, the halo ring. They don't happen all that often. They do need bright sources in the field of view or close to it. But just so you know, those things can happen. Because I had a question recently from somebody who saw this halo ring and their source was there, and they thought maybe it was a nebula surrounding it, and they thought maybe it was a real source or real emission. And we were able to say, no, sorry, it's not that exciting. So do be aware of potential artifacts. Right, UVOT source can only do one image, one extension at a time, as I said. UVOT maghist will actually go through every extension that there is, as long as they're aspect corrected, and give you a magnitude for each extension. So you can do UVOT source and then do +1, +2, +3 on the separate extensions if you want, or you can use UVOT maghist and it'll do all of them in one go for you. Again, it's well, there we go. That's the kind of light curve. So because it's did I say on there? Yes, you can give it more than one image. So if this image has 3 extensions, you'll get a light curve with a magnitude 1 for each of those 3 extensions. But you can also give a file name with a whole list of sources, or in fact a comma-separated variable, a comma-separated list. And then it would run through all of them and create a rough light curve. So obviously you can see the nice detections, but things like this, that's how it plots a limit. So those are the ones that were not detected. So it doesn't plot an arrow, it plots a thing with a huge, great, long negative error bar. There is UVOT product, so UVOT maghist, UVOT source does 1 extension at a time. UVOT MagHist will do all the extensions that are there, but UVOT product will actually try and combine extensions to get a detection if they're not detected in the individual images. I should say straight off that this is a sort of, well, quick and dirty way, in a way. It's you can quickly have a look to get a rough light curve for this, but it doesn't do the whole the bad spot flagging. So the 99 magnitudes and things, they don't get flagged in UVOT product. So I only discovered this last week because I'd used UVOT product before, but only when training. And then I did one with a bad thing and went, okay, why is it that? So I contacted the UVOT team and they said it's simply because this was designed to get a very quick initial GRB light curve, so as soon as possible. And if you start masking out things that are in bad spots, you might get no data. And for the quick and dirty, it's a GRB, we need to know, you won't have a rough idea of the magnitude. So even if it falls over a bad spot, the magnitude's not going to be wrong by magnitudes, if you see what I mean. They will all be fainter, but it's, so my point is, this is good to get a rough idea, but do not rely on UVOT product for publications or anything like that. It's very much just check things. And it is really quite complicated, because if you want to have 3 sigma instead of 2 sigma, you have to use this complicated command on the line. You have to say rebin min sigma equals 3, SNR underscore diff equals 3. It's not intuitive, but it's there. So this is how you would run it if you did. Again, you give it a file name. So that was just a text file with every image that you're interested in on the lines. This can cope with different filters, so you can give it all of your filters, so all the V, U, B, all the W ones, and it will make you a light curve for each one. So yes, you can ignore these bits. That's something to do with, I think it's supposed to plot things, but it doesn't actually affect the magnitudes. So you just ignore the input those. You just give it the source and background region for your source of interest. If you didn't, you can just tell it to use a background, a default background, and it will do that. But I prefer to choose my own. And this is what I said, it does not take into account the SSS flagging, the small scale structure. So be wary of that. You can create a data point from UVOT to read into XSpec if you want to plot an X-ray spectrum and your UVOT things, if you wanted to do an SCD, that kind of thing. So they're just single data bins for separate filters. UVOT does have a GRISM on board, so it can you can get GRISM spectra. I'm not mentioning this here because I have no clue how to do the GRISM analysis. And there are not many people in the world who have got around to learning it, I think. Paul Cowan at MSSL in the UK is the person to contact if you ever have GRISM data and you need help. Or you would contact our Swift help desk and I pass it on to people. But you can do individual data points, so that you could read into XSpec just to plot with an X-ray spectrum, and that's how you do it. It just extracts a bin. I mentioned most things are in image mode. There's also event mode. You have to extract. You have to run coordinator to get. It's a 2-step process. You run coordinator. This is one of the times where I actually do everything on the command line because it doesn't prompt you for everything. You do that, and then you run UVOT screen to screen out the bad pixels, and then you have a nice clean event list. You can use it in XSelect the way that we do with XRT, but there's also a specific UVOT task called UVOT EVTLC, so UVOT event light curve, and it will extract light curves for you from the event data. And so you can either do it for, you have to tell it the binning that you want on the command line. So time bin algorithm equals U means you want uniform time bins, in this case 10 seconds. Alternatively, you can give it a GTI if you want bins at specific times to match up with other things. And again, it will prompt you for everything else, so you give it the input and it'll make you a light curve and the regions that you're using. So that's basically the end. We're not doing BAT here, but I thought I should put in one script, one slide just to mention what there is available for BAT. So if BAT triggers on something, that's typically a GRB, but there are other things that flare up in gamma rays that trigger the BAT. Then we get event data. Then it's nice and easy to analyze. I said I'm not going through it today, but we have threads on our analysis on our Leicester page that show you how to do it. Most of the time, BAT operates in survey mode, collecting things called detector plane histograms, and they have a time resolution of about 5 minutes, I think, and certain energy bands. It used to be basically impossible to analyze those data if you weren't a paid up member of BAT team. However, in the past few years, Tyler Pozoten has written an API to analyze these data. So it's all on his GitHub area, and there's a paper explaining it all. And then absolutely finally, all this stuff that I've gone through is on the Leicester webpage. So we have these analysis threads basically covering what I've done here. And we also have this Swift help desk, which comes to us at Leicester 99% of the time. If you do email it, it'll be me replying to you. But if it's a question about our online product generator, it will probably be Phil Evans. He wrote it. And if it's a detailed calibration question, although you'll probably get a reply from me, I'll be picking Andy's brains. And that's what our threads pages look like. And I am pretty certain, yeah, that is the end. So thank you.